The first keynote presentation will be by Dr. Valentijn of ARC Advisory Group, Europe. His responsibilities include research and consulting in the process industries with a focus on clients in Europe, the Middle East, and Africa. His technology focus is on manufacturing operations management, performance management, supply chain management, and the role of the knowledge worker in manufacturing. His experience includes knowledge of unit processes, simulation and modeling, and business practices utilizing application software designed for manufacturing operations. He is also an independent expert evaluator of research projects for the European Commission in the information and communication domains. Valentijn, the stage is all yours.
Thank you very much. All of you, can everyone hear me well? So I'm very grateful and very honored to be here. I would like to extend a traditional greeting to you. Namaste, namaskara, as some people say here, I believe. I like this concept of bowing to the noble part of us, and I like to also combine the best of all our cultures. So now I need to be swift, otherwise I get trouble with Ganapati Raman. At the same time I need to be slow, so I'll probably go to the Gita to figure out how I resolve this conflict. So I'll have a look with you at, let's say, advanced economies, innovation type activities, and we'll look at the status and the challenges that we encounter today. We'll think about together if we need to focus on efficiency or on innovation. And we'll question if smart manufacturing is a good answer to that, if it's a good strategy to tackle these issues. I'll flip to this slide to give you a background and to make sure we all get on the same vocabulary. I'm using the vocabulary that the World Economic Forum uses. And they divide the different economies, the different countries, in three groups. And the first group is the factor-driven economies, as they call it, who compete on resources, cheap raw materials and cheap wages. And then there are the efficient-driven economies that, in addition, also compete on efficiency. So this is when wages go up, the situation that we're seeing in China. China is the economy is slowing down a little bit. The wages are going up, and so they need to become more efficient to stay competitive. And then we have what we call the innovation-driven economies. This word is not very well known. We more often speak about advanced economies or developed economies. But these, in this terminology, they compete on resources, on efficiency, and also on innovation. Now, of course, this is a simplification. You can very well imagine. It is very clear also in this country. Look at Bangalore, for example, with all this high-tech industry. Clearly, these are in the innovation-driven. They compete on innovation mainly, which is not representative for the rest of the country. But as you can see, it's not completely homogeneous. So it is an approximation. What we will look at is that the advanced or innovation-driven economies, let's say Western Europe, Japan, US, we cannot compete only on efficiency anymore, and that's actually completely consistent with this view of the World Economic Forum. And also, we're not very advanced in social sustainability. As the Dalai Lama said recently, we have done a lot about economic development, but we have not done a lot about happiness development. So that is still something we can look at. So now I'm going back here, and I suppose you cannot read all these statements over here. There are top 10 business challenges that our president likes to put up. It comes from a survey. And you see here increasing asset reliability and reducing complexity and customization. You see insulate business from unprecedented external challenges. You know, maybe some storms or floods or maybe crisis like 2008, 2009. And there is actually only one item here about workforce, about people. This is symptomatic. Basically, all of this tries to shows that companies are scrambling, are struggling, and are trying to find ways to reduce cost or to increase their revenues. In these advanced economies or innovation-driven economies, we see today that generally there is a stagnating growth. I saw yesterday a message that France, the growth is revised from back to 0.2%. The headline is growth is slowing down to 0.2%. Basically, there is no growth. It's a stagnating economies with a few pockets, of course, where things are going better, like the oil and gas industry in the US and Canada in the past years. But overall, the growth is stagnating. And when growth is stagnating, we're not creating jobs. So we have more and more people without jobs. And it becomes more and more difficult to afford the welfare in this country. So it is actually a stressful situation, even if there is a lot of wealth. And so as a response to these challenges, we see a lot of efficiency initiatives, working on resilience, complexity reduction. We see asset lifecycle optimization. We see more automation. Everyone is scrambling. And if you look at what our governments try to do, is they try to stimulate innovation, R&D, and they try to stimulate that we take care of sustainability. And so in the next slides, I'm going to try to reason with you and try to figure out if that would be something that would be interesting for us as a community, for manufacturing, and for the economy. This one we have seen already. Manufacturing, studies show, have an overproportional contribution to trade, export, R&D, productivity growth, and have a multiplier effect on the rest of the economy. So manufacturing is a good area to focus on if we want to focus on growth. Secondly, R&D. If we have more R&D, studies show, this is, excuse me, wrong button. Study from the European Commission shows that in manufacturing and in services, companies that spend more on R&D are more resilient to the crisis. They recover faster from crisis. So R&D makes us more resilient. Also, you should know that when GDP increases, manufacturing GDP increases in a country, and after a while, after a maximum, it starts decreasing. And we start employing more people into services. And so we're losing some of the benefits of manufacturing. Now, if we zoom in, we look in a little bit more detail, we can see that some countries, like Germany and Switzerland, they have a higher percent of industry GDP compared to other countries, like about 20%, like other countries, France or UK, who are much lower in the area of 10%. And so the question is, where does it come from? Now, when we plot these countries against the manufacturing complexity and the technology intensity, we see that Germany and Switzerland, they are at the high end. And so we can conclude from this that if we have high technology complexity and high manufacturing complexity, and we do a lot of R&D, then the manufacturing part of the GDP remains higher, and that has advantages for our economies. So, in conclusion, we need this innovation, we need R&D and innovation to innovate products, to innovate processes, to innovate productivity, new ways of improving productivity, not only the classical efficiency improvements, to lift the technology content, the complexity and the quality of the products we make, to create positive price and demand effects. You know, I'm speaking about iPhone, for example. Is the iPhone 3 times better than a Samsung phone? Functionally speaking? Probably not. but it is 3 times the price. So there is something about this innovation that makes it very desirable. So it has a positive price and demand effect. And we need that for competitiveness, output growth, downturn resilience, flexibility and agility. We'll come back very fast on flexibility and agility, but it also makes us more resilient. And create growth means involving more people in value creation. So we need R&D to boost manufacturing, and that's good for all of us. Now let's look at sustainability. We know also from scientific studies that until 2040, 2050, the CO2 content in the air will continue to increase. And that means that we will see more floods, we will see more storms, we will see more industrial accidents related to that. We will have water and food issues more and more. And this is really the best scenario. If we start saving energy and becoming more sustainable in energy generation, we will get a little better after 2050, 2040 maybe, if everything goes well. So that's reality. Not very nice, but that's the way it is. We also impact our lives and health and economy related to our growth. Look at the traffic. Now, we can develop electric vehicles, but it will not help choking the economy in traffic. Yesterday we spent 3.5 hours in traffic to go to one meeting. Is that efficient? So, sorry, I'm not very good with these buttons. So we realize that digital growth is unlimited. However, material growth on a limited, finite Earth is limited. And so, very logically, very simply, we need recycling, to put this material back into the loop. This is what we call the circular economy now. And we need renewable energy in order to avoid to build up CO2. And we probably also need to think about new urbanistic models and new transportation models. And we'll maybe come back to that. Industry 4.0 also tries to think about that, mixing agriculture, living, industry, leisure, all in the same areas to avoid that everyone moves too much. So that also means clean manufacturing. So, is smart manufacturing the right strategy for that? Now, when I speak about smart manufacturing, I speak about the ensemble of all these initiatives that we have been seeing in the past years. Industry 4.0, Industrial Internet, Consortium, the Smart Manufacturing Leadership Coalition, SMLC in the US, the Catapult in the UK, Horizon 2020, the Research and Innovation Program for the European Union. And so the first question that we can ask, should we speak about industrial IoT or industrial internet, or should we speak about smart manufacturing? Is that important? I prefer to use the term smart manufacturing because it is more wide, it is more encompassing, and there is, I think, more to smart manufacturing than only internet and cyber physical systems. So that's one of my points I would like to make. The other thing that I note in the industry, particularly in Western Europe, everyone is very busy defining what is what. Is this Industry 4.0? Is this IIC? Is this industrial IoT? What is it? But I think we're losing ourselves, we're losing focus, we're getting carried away by this hype in a way. And I think we need to zoom out and focus on our objectives and then decide what we're going to do rather than thinking about what these different initiatives actually do and what they are called. So that is another of my points. So let's have a look at these initiatives and see if they match the needs for the economies. A little note, if I speak about the growth of the developed economies, make sure you do not interpret it as we want a bigger part of the pie, because the economy can grow and grow and grow and everyone will benefit from it. This was an anxiety in the European Union when the countries from the south were joining, they had less wealth than countries from the north, and countries from the north were scared that the south would take part of the GDP away. Actually, this did not happen. We created more and more GDP together, right? So if we make sure that the developed countries grow, everyone will grow. That is basically the concept. Industrial Internet Consortium, I would say it is rather discrete industry focused. It is completely international. It grows very fast. It is very creative. Smart Manufacturing Leadership Coalition exists since 7 or 6 years. It's actually quite old. It is rather process industry focused. And it is mainly existing in the US, but we can definitely learn from them. We have Industry 4.0, which was born in Germany, has become international very fast, and was conceived from a discrete industry point of view, although there are also some process interpretations of it. And then we have Horizon 2020, which is the program by the European Union that really co-sponsors. So they involve companies. It's a private-public partnerships in most instances. There are different divisions. One is the Spire for the process industry, and the other one is the Factory for the Future for the discrete industry. Really focused again on resource and efficiency, while Factory of the Future has also social components. So, you know, they all try to be smart, they all try to improve things. There are different visions, they try to achieve different things, but there are many complementary aspects to them. Another side note is that Industry 4.0 is not very popular concept in the process industries, because many of those concepts already exist in the process industry. We have already self-optimizing system, we have already DCSs where controllers discuss with each other. We have already integrated supply chains and optimization. There are a few other challenges in the process industry, so they have their own buzzwords, they have their own terminology. They use digitization very much. We're looking into modular production technologies and automation. We're looking into remote operation. And typically the US initiative SMLC goes also in this direction. So it's a little bit different, and they're not as aware of Industry 4.0 as the discrete industries. So good, back to our story, 14 minutes left. So what is, I scanned through all these initiatives and I tried to find out, you know, what are the different aspects that we find in them, regardless where I find them, just trying to sum up all the different components of these initiatives. So let's say that on the automation, IT, virtual, digital part, we find digitalization, digital factory, asset information lifecycle management, virtual commissioning, next generation model-based control, big data analytics, industrial data analytics. I'm sure you can cite a few other ones in this range. We have, when it becomes a little bit more physical, we have cheaper and more performing sensors. We have the integration of all this in mechatronics. We have the cyber physical systems that I abbreviate here as CPS. We have the smart manufacturing platform from the SMLC. SMLC tries, amongst others, to create a platform that every company can use an instance of and configure according to their needs. This means the company does not have to do all the integration from scratch. Basically, they have a pre-integrated platform, and they will plug in their supply chain, operations management, asset management, whatever application they want to use. Standardization, interoperability, integrated agile supply chain networks. So these are the things, type of things on the IT automation technology side that we find. On the other side, on the right side, we find actually advanced, what I call advanced manufacturing. And sometimes I think we tend to lose out of sight how important this is. So we find advanced biologicals, advanced chemicals, advanced materials. high strength, high corrosion resistance, high temperature resistance materials. We have biotechnology. We are greening chemicals today. That means we are producing chemicals using bacteria rather than in the chemical route, so it becomes more sustainable, takes less energy. We have smart production technologies as a second group, with advanced forming, 3D printing, performance machining, modular plant technology that we see a lot in fine and specialty chemicals and life sciences, advanced robotics. So these are the, let's say, the manufacturing, the production part of the story, and both are important. And then we also have the human technology integration. We see semantic web technologies, we see learning, improving, we see operator support using Google Glasses or that kind of thing, how to extract knowledge from experienced workers, how to make sure people are part of the system, can interpret their screens very well, and so on. So these are the two, let's say, main groups that we find in those initiatives. And then if I categorize them a little bit more, then I see that one set tries to affect the economic growth from manufacturing. That is, it tries to improve cost, or it then tries to improve the value of what we produce. The value by creating new materials, new treatments, new business models. For example, cost competitiveness, I suppose you know about. And there is another group that tries to impact sustainability. Energy and materials, we have all seen this, but also social sustainability, creating more jobs, creating job quality, creating well-being at work, happiness development. And then also economic sustainability, that means sustainable value chains, not killing the partners in my value chain, as it sometimes happens. So this is sort of a synthesis of what all these initiatives do. And so if we think back of our growth objectives, then actually we see that our government initiatives, they have actually quite well understood what we need, because they do indeed influence both the economics and the sustainability. And that is actually exactly what we want. And we know that we need to focus on the value initiatives because they will create most growth, probably. And that is where we need the R&D. So everything fits well together. With a colleague of mine, Florian Gültner, we put these factors together with a certain number of other factors. We modeled the interactions between these factors. We lumped industries into 5 groups, and we lumped the economies into the 3 groups that I mentioned before. And we made predictions about the growth of manufacturing in the different regions and for the different industries. And I took Europe here as an example. And you have the other countries there as well. And you can see that the advanced, the developed economies, Europe, North America, developed Asia, they have a very moderate growth of 3 to 4%. So you see that even despite these initiatives, it remains hard work. We cannot go to sleep, that's absolutely clear. And if we look at a little more detail of this prediction, you see the red line here, that is the innovation-intensive industries. So that is the electronics, that is the pharmaceuticals, and so on. And you see that they have the highest growth of all, but they start at a lower level, so there is still a lot of work to get that growth really expressed itself in a significant way in the global growth figures. So you here are safe. You have better growth than we have, still, even in 2050. So our economic model shows actually that these initiatives, this innovation and sustainability activities do indeed help our growth. It is certainly better than it is today, but it remains hard work. This one, Neelam will go with you through tomorrow. So now the next question is, what do companies have to do today? So we agree that smart manufacturing is a good strategy to improve economic growth and sustainability. The next question is, what do we do today? What do individual companies do? Now, I would like to warn for this hype. I think industrial IoT and cyber-physical systems, they create a lot of growth, they will create a lot of growth, they create a lot of new possibilities. However, I also do believe that we should not restrict our choices to this, and that we do not have to revolutionize what we're doing in manufacturing right away. We don't have to throw all our systems away and start over. I think we can go step by step. I believe we can do even things with the infrastructure we have today, very simple things that we can start with and create value and growth right away. So that is actually the second paragraph here. And I would like to show you a few examples of those. So this is an example. I took this slide from the CTO of ThyssenKrupp. It's an integrated steel company worldwide, based in Germany. They produce crude steel, they produce intermediate products, they produce finished products like elevators. And one of their challenges was that a rolling plant somewhere in a little valley, which was very narrow, was limited by its capacity. And they couldn't increase the surface, they couldn't increase the size of the plant, so they need to figure out something else. Now, ThyssenKrupp is very, very rigorous in digitizing its company through all its aspects. And here it is about the supply chain. So what they did is to implement pull manufacturing to make sure there was no waiting time. They got their steel slabs exactly on time, and when it was finished, it could be immediately transported downstream for further processing. So the full line was available for its own process, and this way they increased the throughput of this plant with the existing footprint. The F3 factory project is another interesting one. This is one of these EU-sponsored or co-sponsored projects. This has been running for more than 5 years together with major chemical, polymer and life sciences companies in Europe. And the concept is to create smaller production units. They fit into these little containers that you see on the right side, a container that you could place on a truck. So it's small equipment with small tubes, and that increases heat and mass transfer, and basically means that with the small equipment you can still produce a lot of material very quickly. And there were really spectacular results from this project. This modular production technology led to up to 40% of capital expenditure. Operation expenditure with reductions around 20%. Energy consumption reductions up to 30%. Solvent reductions up to 100%. So this is a real enormous step change in sustainability, material efficiency, and effectiveness. And footprint reductions also up to 50%. And in addition to that, it makes the industry much more flexible, because we basically skip the pilot plant. We have the lab installation, we have the pilot plant, then we decide to make a big plant. And if we make a big plant and suddenly the demand goes down, the big plant is running at 40, 60, 80%, is not efficient. With this model, we don't make a big plant, we just add another line. Very easy. And if the line is not used, we transform it and make something else. So this is the flexibility that I mentioned earlier on. Very powerful. And the automation world is thinking very hard of how to adapt the factory and the process automation to this concept. So we're speaking now about modular automation and modular MES or operations management systems. We need to rethink our systems. And one company that has already made a lot of progress on this is Arla Foods in Denmark. They use a standard that is called PECML, and it is based on ISA 88. And they use this to integrate packaging machines in their lines. And this is so highly standardized and automated that they save 3 to 6 months engineering and integration when they buy a new packaging machine and build it into a new line. So imagine the benefits when you need to introduce a new product, which happens all the time in the dairy industry. So these are probably good, let's say, starting points for modular automation, modular MES. Another example along the same lines of modular automation is the transformation of batch processes to continuous processes. Novartis, together with MIT, developed a continuous process for one particular pharmaceutical product that reduced the production time from 12 months to 6 hours. Incredible, incredible benefit. This plant is being constructed in Singapore today. Another example I took from the SMLC, it is operational intelligence. This is very, very nice. It does not require a lot of infrastructure, but it did require a lot of thinking. So people collect here data from their aluminium smelters all over the world, and it's not only a matter of creating dashboards of those real-time data. No, they also use engineering experience and knowledge to draw conclusions from what they see from these graphs. And so every plant in the world has an indication when they go out of their limits, what they should do about it. So this is really analytics combined with real-time information made available worldwide. So it uses internet, but it doesn't use cyber-physical systems. So it's another example of something that can be done today without major infrastructure investments. And that creates a lot of value. Another example is in Volvo. I'm sure our colleague Anne-Marie will like this. There is a simulation, 3D simulation of the car and of the production process done in Siemens. There is a 3D laser scan of the factory building, and with Bentley, with Anne-Marie's, she will talk about that probably a little bit more. We can combine the two and test if the robots do not hit the ceilings, or if the car can go below the beams that cross the factory, and so on. So this combination is extremely intelligent and effective, and I consider it really smart using existing technology. And finally, I would like to show you an example of social sustainability improvements. Social sustainability in companies, it really starts with being courteous and kind to people, while at the same time making sure that performance is at high levels. And there are many companies in the past who have tested this, like Johnsonville Foods in the US and Harley Davidson. Since at least 20 years, we know how to do this. However, it has been largely ignored. And today there is again a new wave, and we see this in France, for example, with the pulled biscuits. They make 10% growth every year in an economy that is stagnating. What's the difference? The difference is, how do we treat the people? How do we speak with them? How do we organize ourselves? So that is a simple magic that can create a lot of productivity, and there are many other examples as well. So, coming, 2 minutes over time. I'll be very short, Rama. So smart manufacturing and IoT are not goals in themselves. We need to go back to our objectives and see where these initiatives can make impact on our companies, on our productivity, on our profitability. We can do it by improving our processes and products, focus on the value, don't forget the efficiency, so become also more efficient. Question our culture and belief systems. Now, don't believe we can only improve 3 or 5 or 7%. We have seen in the F3 factory that with innovation we can improve 30, 50%. So don't limit ourselves to small improvements. Target radical efficiency improvements. Innovate business models. There are many new business models now using IoT. And let's work on sustainability, materials and energy sustainability, just for our survival and also for our efficiency. And then economics and people sustainability for our effectiveness and our safety. And start today. Thank you very much.